One touch.
Sansui.
My name's Chris, and I repair my own audio equipment, and I also show you how to repair yours. So let's get started. Ahead, I'm going to show you the repair and restoration of the Sansui AU9900, including tips on how you can fix your particular piece of vintage audio equipment. By walking through the schematic and showing you in detail how I narrow down a problem to be able to repair vintage audio equipment. Add to that, telling you about Sansui's company history, along with using artificial intelligence to help me repair vintage audio equipment. So I asked ChatGPT, okay, I'm almost sorry I asked. Let's get to the summary. And you can't forget about the bench testing. Pretty amazing, 50 years old. If you haven't already, please subscribe. Alright, you guys know me. I'm going to take a look at the unit first, but I kind of jumped the gun here, and I took the knobs off before I got any pictures. I was looking at that dirty faceplate, and I was thinking, I got to get that off of there. Really, the faceplate, I think, looks pretty good under the dirt, but I just started taking the knobs off, and before you know it, I had the faceplate off. Take the covers off, look in the top of it, make sure you don't see anything obvious. Take a look at the bottom, make sure you don't see anything obvious, and I didn't. So I continued on. Once I cleaned up the faceplate, I went ahead and reinstalled it. Now I'm going to do what I always tell you guys to do, is go through the unit and see what works and what doesn't. I gave it a visual. I didn't see anything with that. And as I indicated, that dirt all over the faceplate bugged me, so I cleaned that up. And then I went ahead and did some bench testing, just see what works, what doesn't. What I found out were the controls were very scratchy. Any of you guys who own pieces of vintage audio equipment, you know what that's about. Sound would come and go. I'd play with the balance control, the volume, the bass, the treble, and you'd get the scratchiness, or one channel would go in or out, which is this normal stuff that you're going to run into in this old equipment. Hopefully those issues will go away when I clean the controls later on. One thing that I knew was broken from my testing was when I hooked the turntable up, and I had a problem with one channel. So I had a problem with the left channel not operating, just with the turntable. The auxiliary worked fine. I hooked a CD player up. There was no issue there. I still had those scratchy controls that I mentioned a couple minutes ago, but I'll get to those and clean those up. But this isn't anything to do with the scratchy control. There's just no audio at all out of the left channel. So what I found was a bad dual transistor, which was a 2SA798, and it's two transistors in one package. They don't make those any longer, but there are ways of getting around almost any issue in vintage audio, and in this case it just takes two SA992 transistors, and you can make your own dual transistor out of that, and that's what I went ahead and did. So in this unit, it is so easy to get to that equalizer block / phono board. As you guys may have seen in my last video with the Marantz 2500, oh lordy, the phono card was the last place you wanted to go in the Marantz 2500. But in this one, it sits right at the top, two cables, couple screws, It is just super simple. So I went ahead and worked on that. Now, sometimes I'll know I've got a problem and I'll continue on for one reason or another. In the Marantz's case, because I knew it was going to be a pain in the butt to fix. In this one's case, it couldn't be any easier as far as the access to the card that I need to work on. So I went ahead, I troubleshot it, I fixed it, and I put it back in. And everything was fine then. I hooked the turntable back up and it worked great, both the left and the right channel. So each repair or restoration of any piece of equipment I work on, they're different from each other. You've seen me in the past approach things differently than I did in this unit. In the AU9900's case, that dirty faceplate bugged me. It was easy enough to take off, easy enough to clean up, so I went ahead and did that. Before I even went in and cleaned the knobs and all that kind of thing, I just got the faceplate cleaned up, as you saw. And then I found out in my initial testing that I had trouble with the phono input. It was easy to get at. I thought I'm going to go ahead and troubleshoot that before I go on. So now I know I have a somewhat working unit. So I know any restoration work I do down the road, if something doesn't work, it's because I broke something when I was working on it. Normally at this point, I tell you guys to download the service manuals for whatever piece of equipment you have, whether you have an AU9900 or another piece of vintage audio equipment you're working on, to download it from HIFIengine.com. But it's come to my attention with comments down below my recent videos that HIFIengine.com is no longer accepting new accounts. I did not realize that. I'm still able to log in. I've had an account for over 10 years there. I've had no issues, and it appears that people who have active accounts can still go on and download the manuals, but anybody who's new can't. I don't know if that's 100% true. I don't know if it's going to stay that way forever. I don't know. But that's a shame because it's such a great resource for vintage audio service manuals, owner's manuals, brochures, all types of information about vintage audio equipment. If anyone out there's got any information about another site where you can download manuals for vintage audio equipment, please put it down below in the comments. There's a lot of restoration work to do before I can get this AU9900 up on the test bench and show you what a 50-year-old integrated amplifier can do. It's pretty amazing. But first, I want to share with you a little bit about the Sansui Corporation and their history. Sansui Electric Company was founded in Tokyo, Japan in 1947 by Mr. Kikuchi. Initially, they had 10 employees and they produced power transformers, input and output transformers, and also choke coils. By 1952, Sansui had grown to 52 employees, and by 1954, they started producing preamps and power amps. They'd been producing the transformers for various companies, and they thought, I think we can maybe produce a better product. And they were making some of the finest transformers in the audio industry at that time. By 1956, they started manufacturing tube receivers. And in 58, they introduced the first stereo tube preamp. Around the same year, in the middle 50s into the late 50s, they started to export their products overseas. And it was the goal of Sansui to build hi-fi products that were better than Fisher or Scott here in the United States. By 1963, Sansui had produced a number of different tube amplifiers and receivers. But in '63, what they did here in the United States is they introduced the 500 and the 1000 tube receiver, which were followed up shortly thereafter in 1964 by the 500A and the 1000A receiver. I have a 1000A receiver in my collection, and it's an amazing piece of equipment from the early middle 60s. So Sansui had a lot to contend with in the United States. You had Fisher, who were making amazing products in New York City. You had H.H. Scott in Massachusetts also making the highest quality products. And you can't forget about Dynaco in Philadelphia. They were making amazing products at a reasonable price, and even Kenwood was here. And you've got Macintosh. How can you forget about them? So they had a lot to contend with in the United States when they came here. So they knew they had to have the best possible product they could have so they could compete. I've talked a little bit about Sansui, the company, and also the products they produced through their first 20 years or so of existence. The only reason the Sansui AU9900 exists today is because of what you just saw. It didn't just happen overnight. They decided to get into the audio game and let's just build a great amplifier. It took decades of dedication to produce an amazing piece of equipment like they did in 1975, this AU9900. Sansui means mountain and water, and it goes back to China several hundred years ago, and it has to do with black ink drawings of nature, trees, mountains, rivers, that type of thing. People wonder if Sansui, the company, this is how they came up with the black front panel and the white lettering. The Sansui paintings were done in different shades of dark ink on a lighter paper or on silk. So did that have some bearing for the design on the Sansui AU9900 and other Sansui products? Maybe, maybe not. I don't know. The one thing that I do know is I think that this is a very attractive piece of equipment. The AU9900 was part of the Sansui Professional Series in 1975. It sat at the bottom of the integrated amplifiers in watts per channel, but that was really the only spot it was at the bottom of this series. The 9900 is every bit the integrated amplifier that the AU11000 and the AU20000 is, except it has less power. Matter of fact, compared to the 11,000, it's almost identical. If you saw them, you would think they're the same amplifier. There's really very little difference other than that the 11,000 has 110 watts per channel, where the 9900 has 80 watts per channel. And even the 20,000, which has considerably more power at 170 watts per channel, the biggest difference, it has power meters. But the look of it, the function of it is very similar to its littler brother, the 9900. So even though the 9900 sat at the bottom of this professional line, it was a top grade amplifier for 1975. Sansui engineered and manufactured all their products to the highest standards in the 1970s. You didn't have to buy the top of the line. All of their products from top to bottom were engineered with the same quality in mind. All right, I'm going to get back into the restoration now of this AU9900. And you guys that follow my videos, you know what I'm going to do. I'm getting rid of those 50-year-old electrolytic capacitors. It's time for them to go. There's no question about it. It's going to make this unit sound its best, and even more important for me, it makes it reliable. So when you hit that power switch, you're not thinking it may be the last time. Because if you've got 50-year-old electrolytics in your piece of audio equipment or any piece of electronics, every time you hit that power button in your piece of equipment with one hand, you should have your rabbit's foot in the other, because eventually you're going to have a failure of your electrolytic capacitors. It's not a matter of if you're going to have a failure, it's when. I do enough of these restorations to where I have almost all of the parts I need in stock. Sometimes people ask me, can I have your build list? What parts did you use? And I don't have one. I just start the restoration. As far as what brands you should use for your replacement capacitors, just use a quality name. I've used them all. I can't tell the difference in the sound quality. Other people can write an entire encyclopedia about the sound that they heard with a particular capacitor. I can't. Just use some quality capacitor and know it's going to be a lot better than that 50-year-old one that you're replacing in your piece of vintage audio equipment. Earlier, I had removed both the top and the bottom cover of the AU9900, as I always do, to take a look to see if I would see anything that would prevent me from powering it up. And as you guys have seen already in the video, I didn't. I powered it up, had a couple issues, and got those behind me. And now I'm ready to start the rest of the restoration. I am so impressed with the way this AU9900's laid out. I hope you can see in the video here how much room there is in this unit and how neatly it's laid out. You don't have to be an expert in electronics to see some thought was put into the layout of this unit. The way this unit is laid out will make it so much easier to restore, or if you ever had to repair this unit. Some units from this era are not done as well as this one is. This is one of the finest examples from the late 1970s of how it should be done. This is not a monster receiver from this era with 200 or 300 watts per channel and having to cram a ton of stuff into a chassis, but the mechanical engineers at Sansui did a wonderful job laying this unit out. Laying out a unit like this with any type of electronics took a lot of thought and a lot of care and thinking about the person who was going to have to repair it down the road. And in addition, this would allow the assembly line to be much more efficient when they were manufacturing these units in Japan. I'm going to show you the entire restoration of the Sansui AU9900, but first, I want to share with you a few of the features of the AU9900. The first thing you'll notice on the AU9900 is that the RCA inputs are on the side of the unit, not at the back like it is on most pieces of vintage audio equipment. And it's full featured. It supports 2 turntables, has 2 auxiliary ports, tuner port, supports 2 tape decks. It also has adjustments for the phono cartridge. Any turntable hooked into phono 1, you can adjust the load resistance between 30,000 ohms, 50,000 ohms, or 100,000 ohms. It also has a sensitivity switch. You can use the sensitivity switch to adjust your turntable to better match the rest of the components in your system. Seeing that they added an adjustment for the resistance of phono 1, I found it a little bit unusual. They didn't include some sort of an adjustment for the capacitance. That way you'd have more flexibility. You could change the resistance and capacitance, but they didn't do that in this case. So these are all on the right side of the unit. On the other side, on the left-hand side, this is where you hook your speakers up. In addition, there are RCA jacks that you can hook up a separate preamplifier or a power amplifier to this unit. Most integrated amplifiers of the day supported 2 speaker systems, just like this AU9900. The same with being able to split the amp if you want to, run the preamp section with a different power amp, run the power amp with a different preamp if you want to do that. So it's pretty standard for the day. The back of the AU9900 is different than any piece of vintage audio equipment that I have. The only thing at the back are 3 AC receptacles and a power cord. There's not even a fuse. Normally there'd be a fuse in the back, and normally you'd have all those RCA connectors that I showed you, and you'd have the speaker connectors, everything that a normal integrated amplifier would have. You'd be looking at it right now, and you don't see any of that. If there wasn't a tag on the back that said AU9900 integrated amplifier, I doubt most people would have a clue what this is, and guessing that it was a piece of vintage audio equipment probably wouldn't be very high on the list. So I just mentioned there's no line fuse at the back of the 9900. Where's that at? So let me show you where that is. You have to remove the top cover, and it's near the back right hand corner. And while I'm talking about the line fuse, notice there's a voltage selector switch. Anything from 100 volts to 240 volts is an easy changeover in this unit. In some units, it's not so easy to change the voltage in your piece of vintage audio equipment if you need to for some reason. But in this piece of equipment, you could run it anywhere in the world. practically, and it would be fine. All it is change a switch setting and you'd be ready to go. Now let's look at the front of the Sansui AU9900. I like the way this looks. Like that black faceplate, the white lettering, the aluminum knobs mixed in with some black along the bottom. I just think it's laid out very nicely, and it's a very attractive piece of equipment. And along with that, all the controls have a very solid feel. Now I'm going to talk about some of the functional features. We already went over that it can support 2 turntables and 2 tape decks and 2 sets of speakers. Didn't talk about the tone controls at all. I'm going to talk a little bit about them. There's a bunch of different adjustments, more than what you typically would see in an integrated amplifier. There are triple tone controls on this 9900. There's a bass control with 3 turnovers. There's a treble control with 3 turnovers. Then there's a mid-range control also. So you've got quite a range to play with tone controls if that's what you want to do. I never used them much, or really used them at all. I was more adjusting my speakers or what have you, try to get the sound I wanted, but I can certainly appreciate a unit like this, especially if you're in a position where you cannot set your speakers wherever you want. Behind the faceplate are these same controls, and coming up I'm going to show you the restoration of this section of the AU9900 as well as the rest of the unit. I know some of you have AU9900s, but many of you don't. So now I want to show you a little bit about how to approach any restoration or any repair of vintage audio equipment. Doesn't matter the brand. Doesn't have to be Sansui. It can be Pioneer, Marantz, or Macintosh. It can be any of them from this era. I've recently received a second Marantz 2500. Yes, a second one. And here I sit with my coffee at 2 o'clock in the morning with it. The previous owner of this 2500 had been told it'd be 12 to 15 months before it could be looked at, and that's why he sold it, because it was broke and he just didn't want to wait that long. And that's the situation that many of you are in. There's not a technician to work on it, or there's nobody you would trust with it anyway, because if you're having your piece of vintage audio equipment repaired, you probably care about it, and that's a big problem in today's world. So this is why I try to put some information in my videos that may help you keep your own vintage audio equipment running. Whether you're looking to repair or to restore your piece of vintage audio equipment, before you start, you must have the service manual. If you don't have the service manual, don't start until you get it. Some of the service manuals that you'll find available for download on the internet are not very good quality, like this one is that I found, because it's a lot easier looking at something like this, nice and clear, than it is something like this, which makes it much more difficult to read. So if you don't find a good scan right away of the service manual you're looking for, just look around a little bit more and you'll probably find one. Now you're probably thinking, what do I do now? I've got a piece of vintage audio equipment that I need to fix or I'd like to restore. I've got the service manual, but where do I start? I get it. You remove the covers on these pieces of equipment and you look inside them and you just don't think there's any way to ever figure out what's going on. But you can figure it out if you take it a step at a time. Probably the most important step is the first step. It doesn't matter if you have a piece of equipment that you need to repair or one that you're going to restore. Understand before you start what works and what doesn't. Make sure you test out that piece of equipment in every possible way. Test every input, use every control, push every button, and know where you're at before you start your repair or restoration. You want to do this with a repair because you want to narrow down that problem. When you look in your piece of equipment, you don't know where to start. If you can narrow down where the problem is, you can eliminate a lot of that unit, and then you've got a good chance of fixing your problem. If it's a restoration, there are times where you're going to make a mistake. You're going to put one of your replacement parts in wrong. You're going to forget to solder a pin. You're going to bust a wire while you're inside the unit. A lot of things can happen, and if you know before you started what was working and what wasn't, it'll make it much easier trying to find the issue. I'll be talking about the AU9900, but keep in mind it doesn't matter the make, the model of vintage equipment that you have, whether it's a receiver, an amplifier, a preamplifier, a tuner, whatever it is, there's going to be a service manual, and it's going to be very similar to what this AU9900's is. So in the AU9900's service manual is a block diagram, and this gives you a layout of all the different boards and their assembly numbers. The block diagram's a good spot to start to understand what's inside the unit. You get to see what's outside the unit every day when you look at it, but this block diagram gives you a layout of what's inside the unit. The block diagram also shows the signal flow of the AU9900. It shows you at the left where the signal comes in and at the right where the signal comes out, and shows you all the different assemblies of where that signal has to go through to get from your RCA inputs to your speaker outputs. I was talking about the tone controls a few minutes ago in this AU9900, so let's see where those are located on this block diagram. 4 board assemblies make up the tone controls in the AU9900. They're the F2575 mid-range circuit board, the F2576 bass and treble circuit board, the F2577, the turnover selector board for the treble, and the F2578, the turnover selector board for the bass. What this shows you is those 4 assemblies in the AU9900 are associated with 9 controls on the face of the AU9900. It's important to understand how your piece of vintage audio equipment is put together, whether you have a 9900 or not. Once you understand how your unit is assembled, it'll make it much easier to work on it, whether you're repairing it or restoring it. This is 8 of the 9 controls that I've just talked about when I was doing the restoration, and I had them out of the chassis. The only one missing is the mid-range circuit board, and that's a little separate circuit board in itself. But you can see the larger board is the bass and treble circuit board, the F2576, and you can see the push button switches. There's 6 of them. 3 of them are for the treble and 3 are for the bass, and that's the F2577 and the F2578 that I just talked about. And they connect to the bass and treble circuit board via a cable. This is the F2576 bass and treble circuit board as I was restoring it on the test bench. And you can see a gap in between the other 2 controls that are pointed toward my shirt. That's where the mid-range circuit board sits, the F2575. Without having that mid-range control in there, this 9900 just wouldn't look right. In summary, so I'm just going to go over the circuit boards real quick and their functions. The F2575 is used with the mid-range tone control. The F2576 is used with the bass and treble controls. The F2577 is used for the 3 possible treble turnover frequencies, and the F2578 is used for the 3 possible bass turnover frequencies. I hope this simplified for some of you guys how your units are laid out, because once again, I understand when you take the covers off and you look, you have no idea where to start. But if you've got that service manual, it will really help you to put together in your mind where these assemblies are and what they do. There's a lot more to show you with this Sansui AU9900 repair and restoration, including pushing this 9900 to its limits and beyond on the test bench. But first, a word from our sponsor.
Lover, but I'm no engineer. Right, Stanley? The last time I went shopping for stereo, I was so busy checking out the specifications that I didn't have time to listen to the music. So today, I brought Stanley along. He's an audiophile. Right, Stanley? He checked out the specs while I concentrated on the music. And we both agreed on Sansui. Beautiful engineering, beautiful music. Sansui. There's even music in the name. Right, Stanley? Stanley?
Let's look at a few more of the assemblies in the AU9900. My goal in this video is to get you comfortable with your piece of equipment. If you've got an AU9900, great. But as I mentioned, if you don't, all of this information is going to carry over into any piece of vintage audio equipment that you'd like to repair or restore. First up's the F2570 equalizer card, which is your phono card. You'll notice here on the block diagram, it says F2070, not 2570. Now, I believe that's just an error in the manual because every other reference to this card in the service manual indicates F2570. Back in the day, if they would have had an error like this in their manual at the service center, because there is no internet, it would have been a document. They would have gone ahead and used a little bit of whiteout or a piece of white tape, and they would have put the correct number in. And that's what I'm going to do here. I'm going to use a little computer safe whiteout and put the correct number of what the equalizer unit actually is on the document. I just wanted to point out that the service manuals, although they're quite accurate, they're not necessarily 100% accurate. So first of all, I think I ought to go over why Sansui calls the F2570 an equalizer unit. As I indicated before, this is really your phono board. So why would they call it an equalizer unit? Some manufacturers call their phono boards equalizer amplifiers. And I think that's a better name for it than just an equalizer, because this board in the Sansui 9900, it has two functions. One as an equalizer and the other as an amplifier. And first I'd like to talk about the amplifier function of this F2570. Looking in the service manual will help you understand a little bit more about the F2570 and how an equalizer amplifier works in a piece of vintage audio equipment. So if you look at input sensitivity and impedance in your service manual, and this can be any receiver, any integrated amplifier, as I indicated before, it doesn't have to be a Sansui AU9900, you'll see it gives you a specification and it says 1 kilohertz for rated output, and it shows the different inputs: phono 1, phono 2, the tuner, auxiliary ports, the tape ports. Many times you guys will see me with a piece of equipment on the test bench, and I'll be talking about a 1 kilohertz sine wave that I'm putting into the equipment, like I did with this AU9900 that you're going to see coming up. What that specification means is with the volume control at 0 dB, which means at the maximum setting. You've taken your volume control, you've turned it all the way to the right. Each input needs these particular amounts of voltage to be able to output that full power, in this case 80 watts per channel. And remember, these are minimum voltages. All of your auxiliary equipment you have hooked up to your receiver or integrated amplifier, they're going to output more than this. Any tuner, CD player, or cartridge, for an example. My Shure V15 outputs 4 or 5 millivolts, so more than enough power to not have to crank the volume knob all the way over to be able to hear it. The reason they call this an equalizer is there's something called an RIAA curve, and it was a process that was created for record and playback. It involves pre-emphasis and de-emphasis. I won't go into this very much, but I just want to tell you that when a record is cut or created, it is de-emphasized in the lower frequencies and overemphasized in the higher frequencies. This was done to allow longer playback of a vinyl record. But if you've de-emphasized something and overemphasized something, what do you have to do? You've got to equalize it. And that's what this board does. It takes those low frequencies that were reduced during recording and the high frequencies that were boosted during recording, and it brings it back to a flat response by doing the exact opposite of what was done during the recording process. This is how you end up getting a flat response and having your vinyl records sound like they're supposed to. So you can see why this board's called an equalizer, and as I said earlier, I think it should be called an equalizer amplifier because there really are two distinct parts to this assembly. Also in the service manual is a block diagram of the F2570 that shows you more details than the other block diagram showed you earlier. And what it shows you here on the left-hand side are the RCA inputs for the left channel. Now the right channel is identical to the left channel, so they just show you one channel. On this diagram, you can see a lot more details. They show you resistors, they show you capacitors, they show you ICs, which they consider two transistors in one package, an IC, and they show you the signal path, where it looks like a bow tie here. They show that coming in from the RCA jacks and then coming out here at the right side of this diagram. And they show you B plus, which is your voltage, and B minus, which is voltage. But you notice on this whole diagram, they really don't give you any values of resistors or capacitors or much detail, but it gives you more detail than what we were looking at earlier when you're looking at the block diagram of the entire unit. The service manual also contains the F2570 equalizer board's schematic. That's shown here on the left side of this picture. On the right side of the picture, it shows the two diagrams we already went over. The block diagram of the entire unit and the block diagram of the F2570 equalizer. The service manuals are just packed with information to help you repair or restore your piece of vintage audio equipment. So let's check out that schematic a little bit. So over here at the left, I show the schematic for the F2570, and in the middle, I have a picture of the F2570 installed in the AU9900. And I think this will help explain what I'm going to try to talk about here, is that this F2570 is both channels on one board, and that's why you see the designation 2570. And the left channel is, if you could take a marker and go right down here, the left channel is the top part of this board, the right channel is the bottom part of this board. And each section, both the left and the right down below, show different details about the schematic. Unlike over here on the right, when we looked at the equalizer block, it didn't show us any type of designations. It showed us a little symbol for a resistor and a capacitor, but it really didn't give us any more information. In the schematic, it shows you all the details. And in Sansui's case, in this unit, they show all the details on the left channel. I'm going to just show you one resistor here. I'm circling it. It's R09 on the left channel. And they have its value, 120K, 120,000 ohms. And if you go down here, down to the right channel, the same resistor says R10, which is the way it works in this unit, is all of the right channel components are even. All of the left channel components up here are odd. But you'll notice back down here on the right channel, R10, they don't have the designation 120K, because they already told you that back up here on the left channel. But what they did add, they added a voltage. They're indicating when this board works correctly, you should have a positive 0.6 volts at this point. They didn't add that up here. And the reason they did it this way, for clutter, because you put so much stuff on here, you wouldn't even be able to read it. So they split the information between the two channels, because the two channels, they're identical. They're exactly identical. They split right down the middle here, and they certainly look the same, don't they? You can even see that transistor I changed out earlier. So up on the left channel, it shows you what voltages you should have here. Plus 32, minus 33. You go down to the right channel at the bottom here, and they don't show anything. But that's telling you that you should have plus 32 here, and you should have minus 33 here. Pin numbers are the same, pin 1, pin 2, but on the output side, which we saw over here on the right, they designated that's the output. And if we go back to the schematic on the left channel, they actually show you the pin number. It's pin 3. So they're saying the left phono comes out of this amplifier, equalizer, out of pin 3. You come down here to the right channel, it comes out pin 6. And down here on the right channel, I showed you that 0.6 volts, but they also give you other voltage points. You should have 0 here. You should have positive 0.6 here, etc. So they're telling you what you should have at different points for this board to operate. As I've indicated in some other videos, and maybe even in this one, there's not too many people that understand how this really works. There's a few experienced people out there that do, but most don't. And so Sansui, back in the day, they didn't know what level of technician was going to be working on this. Most people weren't going to understand how it operated. And so what they did was to give you all this information. Because this was long before the internet, so there was no downloading documents or getting online help for any of this equipment back in 1975. If you remember earlier, I had a problem with the left channel on this card, and I said after some troubleshooting, I found a transistor and I fixed it. So let me show you how I approached the problem I had, and this will carry over to any problem that you may have with one channel or another, like I did. I had my right channel working on the phono section. My left channel didn't work. But this could be a problem with your preamp. It could be a problem with your power amp. You approach the problem the exact same way, and I'm going to show you how you do that. If your equipment is in need of repair or restoration, you're going to need some basic tools. Variety of screwdrivers. You need a small set of needle nose pliers. You need a small wire cutter, something that's appropriate for the size of the wires that are in these units. Just some basic hand tools. You're also going to need some other tools specific to electronics, as well as some measurement devices. You need a multimeter to work on this equipment. You don't need a $500 fluke multimeter, but you don't need a $3 one from your flea market either. You also need a soldering iron and solder. You don't need a $100 soldering iron, but don't buy a $3 one. Just like with the multimeter, do a little research up on the internet and buy something that's decent at a reasonable price. With basic hand tools, a digital multimeter, and a soldering iron, you'll be able to repair about half of any of the issues that may come up with vintage audio equipment. Other than tuner alignments and vintage audio equipment, there's only one more device you would need to fill in that other 50% and be able to fix any issue with your vintage audio equipment, and that's an oscilloscope. My Tektronix oscilloscope's about 40 years old, and it works fine for vintage audio equipment. The only issue you have is it's 40 years old, and it's probably going to break on me someday, but it's a great scope to use on vintage audio equipment. Or I just did a review of a Handtech 6022BL PC oscilloscope, and for under $100 you can get an oscilloscope, you can get a signal generator that goes right on your iPhone, and you can get the cable to make it all work. The downside to this setup is that you need a PC for it to run on. Of course, my standalone Tektronix doesn't need that. So whichever one you pick just depends on your situation. You've got the 40-year-old oscilloscope that's going to run you a couple $100. You've got the digital oscilloscope that's going to run you $100 or so, but you need a PC. Either one will work fine for you when it comes to troubleshooting a problem in a piece of vintage audio equipment. So now I'm going to show you how I troubleshot the issue I had with this AU9900, where I had no left channel from the phono input, using these same tools I just showed you. The left channel was totally dead, absolutely no audio. The right channel sounded great. I know I mentioned this before, and you probably get sick of hearing it. You must have the service manual for your piece of equipment before you take the cover off, before you try to attempt to fix it. So I've got my service manual, and I'll go to the table of contents and look for that F2570 equalizer amplifier board. Now I'll go to the page that has the F2570 equalizer board schematic diagram. If you've got one channel operating properly, you've got a big advantage when it comes to repairing the broken channel in a piece of vintage audio equipment. And again, it doesn't matter if it's this piece of equipment or a different piece of equipment. I talk about experience working on this equipment, but who's got more experience than that other channel? Nobody knows this equipment as well as that other channel does. So that's a big advantage. You can take a look on the good channel and see what you've got, whether it's a voltage, whether it's a signal, whatever it happens to be. You're able to check the good channel and compare it to the bad one. So that's a big help when you're looking for a problem and you may not be very experienced. Or if you are experienced, it's a big help. But before I get carried away tracing out signals, the first thing you always want to do when you've got an issue is check the voltage. All you need is that digital multimeter and make sure you've got voltage to the board. In this board's case, almost certainly the voltage is okay because the right channel's working properly. The voltage that comes from the regulated power supply for this card is used by both the left and the right channel. They're not separate voltages that are coming from the power supply. So most likely that's okay, but you want to check it just to be sure. With the voltages being fine, now it's time to move on to some more troubleshooting techniques to try to figure out what's going on. And this is where having a signal generator and an oscilloscope is so helpful. Could you fix this problem with just your multimeter? It's going to be difficult because at this point it's so much easier to feed a signal into the phono inputs and take a look at it at the outputs. It's not totally hopeless if you just have a multimeter, because you can go in there and see if you've got a bad transistor. You can still measure resistance between the base, emitter, and collectors on these transistors and get an idea if the transistors are bad. You can look for a shorted capacitor. So it's not totally hopeless. It's just easier with a signal generator and an oscilloscope to find an issue with one of the two channels. Now I'm going to hook up my signal generator to the phono RCA inputs on the side of the AU9900 and follow the signal through the phono section and see where my issue is. I can also compare, as I mentioned earlier, the good channel at different points to see where the signal's good and where I'm losing it. So on the schematic to the left are the RCA inputs, over to the right's the output. And you can either use phono 1 or phono 2, it really doesn't matter, because out of pin 3 we should see the amplified signal through this card. I keep talking about pin numbers, but I think I ought to show you where those are on the card and on the connectors that come into this card. There's 4 different pins that we're concerned with: pin 1, pin 2, pin 3, and pin 8. So pin 1 is the positive 32 volts from the power supply. Pin 2 is the negative 33 volts from the power supply. Pin 3 is the phono output, and pin 8 is the phono input. Now we know pin 1 was good. We know we have our voltages on both pin 1 and pin 2. So the two important ones are really pin 3, which is the phono out, and pin 8, which is the phono in. Pin 3, the phono output, goes directly to the preamp after this card is amplified that low-level signal from your cartridge. And pin 8 is the input that comes directly from your RCA jacks, and that is a very low-level signal that's created by your cartridge in your turntable. Keep in mind in these graphics I'm just showing you one channel, the left channel, the one I'm having a problem with. The right channel, we'll be using him too to compare signals, and his input comes in pin 11 from the RCA jacks, and his output goes out pin 6 to the preamp. So how low is low? Most modern moving magnet cartridges put out 3 or 4, maybe 5 millivolts. So it's pretty darn low, much lower than the preamp can use to get your volume up to any usable level anyway. So that's why we have in this unit this F2510 equalizer amplifier, and every unit, doesn't have to be this one as I mentioned before, it can be any vintage unit that has a phono stage in it, operates similar to this. And you may be thinking, well, how much does it amplify it? How does that work? Well, I did a little bit of research because you guys know I'm a hobbyist, not a professional, so I don't really know what I'm doing, but I've gotten pretty good at doing searches on the internet. And phono stages generally for a moving magnet cartridge, which this unit supports, and most of you guys out there have those. Some of you have moving coils. The general consensus is it's about 40 dB of gain. And once again, you're probably thinking, what does 40 dB mean? What is the voltage gain from 40 dB? What is the power gain from 40 dB? Some people know it, but a lot of people don't. So 40 dB gain is about 100 times the voltage gain. If you've got a 3 millivolt output cartridge and this F2570 is amplifying that times 100, so it's 300 millivolts. And remember, this unit has a sensitivity switch on it too, that you can change from 2, 4, and 8. And that's going to make a difference what the sensitivity switch you have on here of how much gain you get out of this phono stage. With 300 millivolts coming out of the phono amplifier, that's more than enough voltage for the preamp. So I think I can reach the sensitivity switch for the phono, and I'm on 2 millivolts right now, the 2 millivolt sensitivity. So let me put it up to 4 if I can, and see if you notice that the amplitude of the output went down. And if I go to 8, even more. So you're able to use that sensitivity switch to match up the output voltage of your cartridge to the AU9900. And that way you can have your volume close between components. A lot of you guys out there, maybe you've got a turntable that you have to turn the volume control up further to get the same output than you would from, let's say, your tape deck or your CD player. Or maybe you got the opposite problem. But in this unit, you'd be able to fine tune it to where the volume control would be able to be uniform no matter what component you're listening to. One thing I've learned over the years, the less you have to put your hands in a unit, the better. Better for you, and more so, better for the equipment. So you may notice the scope probes are hanging down the front of the AU9900. And the reason they're doing that is I've taken a piece of 20 gauge wire, left the insulation on, stripped both ends, and then I've pushed that wire down into the connectors so I can look at the signals. And I've taken that wire just long enough to hang over the front, hook the probes to it, so I don't have to worry about a probe coming loose inside the unit somehow. Maybe I bump it, maybe it just comes loose. It happens, shorting something out and causing more issues. Now you can compare your good channel with your bad channel. As I mentioned, the best thing to do, get a signal generator, input a 1000 hertz sine wave, and just take a look at it through whatever circuit you're trying to troubleshoot. If you've got one channel that's got an issue, normally it'll be readily apparent there's something wrong. Like the image on the scope here, channel 1 was hooked to the left channel, channel 2's hooked to the right channel. Well, the right channel looks like a normal sine wave. The left channel, not so much. And as I said before, I'm troubleshooting an issue with the phono section of this amplifier. But this works for a preamplifier, an amplifier, a receiver, any piece of equipment where you have one channel working and the other one not. At some point, you have to get down onto this card to troubleshoot the issue you have. It was nice that we had connectors here, that we could see the signals coming in and going out, and we determined that there's something wrong with the left channel. You have the sine wave coming in, and the sine wave going out looks not correct. So, but where is the problem? And that's where you use the schematic to find different points to check the signal. And remember, if you're looking at something, you're not sure if that's right, you can look down here on the good channel. These are identical channels, so you've always got the good channel to compare a signal to. The issue in here is when you're in here with a scope probe, a meter probe, you can short things out easily. and you've got to be very careful. And that's why you really should use some sort of test clips in here. And what works very well, I don't know if you can see this or not, I'll try to set it here. It's these little mini grabbers. They're used a lot in electronics. I don't know if you can see the little pins moving, but you press this and these pins open up for you. And you can see it's all insulated, it's all plastic, and there's little wires that you can purchase that go with these. There's a little pin here on the end, and you can just go ahead, put the wire in, and then you've got this piece of wire. If you can see that, I don't know. You've got the connector, you've got the little test lead, and you've got the wire here, and then you can bring the wire outside the chassis, and it's all insulated. You have no worries. And these little grabbers can get onto most pins. Like if we look here, we want to look at R45. There's a resistor right here. See if I can see it to get on it. Yeah, I'm on it. And now that's a lot safer than going down in here with a scope probe, a meter, whatever it is you're using for test equipment, because you've got a lot better chance of shorting something out in here, especially when you're new doing this, and even if you're not new. And another thing you should always do is have the power off while you're hooking these up, and that gets rid of any risk whatsoever. So now you're able to safely trace out the signal from the input to the output and see where the issue is. If you're comparing the two channels with each other and you find that there's a difference in the signal, you've got to be able to repair it. You've got to be able to say, okay, I see a difference. Now what do I do? This board sitting down in here, I've taken my test leads, I have them hooked up, I see a difference. Now what you have to do is to be able to first of all, look around the area and see if you see anything that looks obvious. I've seen components that were burnt, transistors with legs blown off. It kind of gives you an idea if something bad happened. Something's discolored. Most of the time, resistors are never going to go bad. They do occasionally. Usually they go bad when something bad's happened in the circuit and they've got burned up, but they'll take quite a lot. Many times it's going to be a transistor or a capacitor or a combination. Sometimes a transistor goes and takes another transistor with it, that kind of thing. You can have multiple components go bad in an area. But now the idea is to figure out what's wrong. And with that, you have to get this board loose. You have to remove it. So with the board loose, if you want to continue doing some troubleshooting, you've got to be able to get those connectors back on. And sometimes there's not a lot of slack when you're holding it up like this. And I'm having a little trouble getting the one on because I don't have a whole lot of cable to do it with. I am able to get it back on there, but sometimes you got to find a tie wrap somewhere else in the unit. Somewhere you can usually get that extra inch or two if you need it. But now you've got it hooked up, and it will work just like if it were screwed down into the frame. The issue is you've got to be very careful now. It is loose. You've got to make sure that that board does not short up against the frame, because that entire frame is metal, it's ground, and most likely something really bad's going to happen if that artwork side of the board touches that frame. But now I can pull it up, I can get down under there and take my scope probe or take my meter and do more troubleshooting. And certainly I can see the under part of the board to make sure there's not some issues with the artwork, and there are sometimes. You'll find cracked artwork or questionable solder joints. So I'm able to take a look under there and still have it powered up. But as I indicated, you've got to be extremely careful when you have it powered up and you have an assembly loose like this, because it's easily shorted out. I've found that a piece of cardboard works well in most situations because it's flexible enough to bend around a little bit to get where you need it, but it's also steady enough that it doesn't collapse like a piece of paper would or some other material. Now sometimes I'll use a piece of paper just to protect from scratching something. These assemblies have a lot of sharp points on them, and it's easy to scrape your paint on the inside of your chassis, and why do that if you don't have to? So I'll put a piece of paper under an assembly sometime just for that reason. After troubleshooting, you think you may have a bad transistor. How do you go about testing that with your multimeter? Up here on YouTube, I found a great video about how to test silicon transistors by Marcus Fuller. And in under 3 minutes, he explains how you can test a transistor and tell if it's a PNP or NPN.
Hi, I'd like to show you how to test a transistor and also to identify whether it's an NPN or PNP using just a simple multimeter with a diode checker on it. Most multimeters now have a diode checker on it, even the cheap multimeters. So we're going to switch the multimeter to diode check, and that's just a little bit of blue tack, and here's a transistor for us to test. So with your leads, just check between the contacts of the transistor, nothing between any of them, swap them over, try them all again, nothing at all, no readings whatsoever, so therefore that transistor is dead. So now I'll get a new transistor and do the same thing. Check between those two. Aha, now we have a reading. So if I move that one over, we have a reading there as well. So we have 2 negatives there and there, and 1 positive, which is here. So that makes this an NPN transistor. And it also makes this single leg here the base. So that is sort of working like this. You have the diodes sort of facing outwards there, and that would be your base, and that is the symbol for it. Now I'll test another one and do exactly the same. Check between those two, nothing, nothing, nothing. Swap them over, nothing. Now we have a reading, and we have a reading there. So the positive is reading on those 2 legs, and the negative is reading on just this one here. So that's 2 positives and a negative, so that makes it a PNP transistor. And again, that makes this one the base. And that is these 2 diodes sort of facing inwards. There's your base, and that would be the symbol for it. So I hope that's been some use to you. And if you like this video, please give us a thumbs up because it helps in the searches. And I'll do another video very shortly. Thank you very much for watching. All the best.
The only thing I can add to this video is there are times also when you can have a bad transistor that has shorted leads, not just open leads like he showed in the beginning. You can have a transistor where one of the leads are shorted to another, and that would also indicate a bad transistor. So another way to test transistors is with a device that's made to just test transistors. That's all it does. And I've had this Atlas DCA Pro for a few years, I don't know, 5, 6, 7. And I work on enough stuff that it justifies a purchase like this. Nowadays, they're a couple $100. When I bought this, it wasn't, I don't think it was $100 and a quarter, $150, but that's the way everything's been the last few years, right? Inflation. But I just wanted to show you how this worked compared to doing it with a meter. This device will test any transistor. I've never had one that it wouldn't test, and it's quite easy. You've got 3 leads that will go on the emitter base collector, and in this case it doesn't matter where you put them. You know, just pick the leads up, put the leads onto the transistor and turn it on. It takes a second, and up it comes, and it says it's a PNP silicon transistor with an HFE, which is the gain of it, of 157, and it tells you that the red lead is on the base, the green's on the emitter, and the blue's the collector. But it's very simple, very easy to test, easier than with a meter. And if the transistor tests bad, it'll give you an indication of what it found. What I use this for, that really works well for, that you can't use a multimeter for, is to gain match transistors. When you gain match a transistor, really you're gain matching two transistors. You want that transistor in the left channel and the right channel to amplify your audio signal exactly the same. Some areas of vintage audio equipment you don't have to worry about it, others you do. Like the two transistors I used when I repaired the problem I had with the left channel of this phono equalizer amplifier assembly. I used this device to gain match those transistors. So this device is really nice for that. I'm not saying to go out and buy one, because most of you will be able to get by with that inexpensive digital multimeter to do most of your troubleshooting. But if you get into this hobby a little bit deeper, this is something for y'all to research and see if it would be a tool that you could use. So both of these methods, both with the meter and with the DCA Pro, you saw the transistor just sitting out on a table. It wasn't in circuit, so you may be asking, can I test this in circuit without removing it? And the answer is yes, you can, but keep in mind there's multiple conduction paths possible, and you may get some flaky results, and you may not be sure if it's bad or not. So when in doubt, remove the transistor and test it by itself. You guys know how I approach projects, so even though I had a problem with one channel on this board, I was going to change out the old electrolytic capacitors and any transistors that are known troublemakers or any diodes. So with this board out, I wasn't only going to fix the problem I had, I was going to change out not only the one 2SA798, that's that dual package transistor that was causing my issue, I'm going to change all four of them in both channels. And the reason for that is they have a little bit of a reputation of going bad after 50 years. Some of them do, some of them don't. I've had a few, not in this unit, I had just the one, but I've had 3 or 4 of them bad. And so that kind of tells you, you ought to go ahead and change those out, in my opinion. A lot of people, they don't do that. And that's up to them. It's their equipment. They can do whatever they want. I'm going to get in there. I'm going to change all 4 of those 2SA798s, along with putting in fresh electrolytic capacitors and changing out a couple of the small value electrolytic capacitors with film capacitors. So why use film capacitors instead of electrolytics in some areas? Years ago, when I first started going into this hobby, I read a lot of the forums, and the audiophiles, the experts, they all said that film capacitors were better. They were better for audio. Any small value electrolytic capacitor in the signal path will be better off if you change that out with a film capacitor. So I started doing it. Have I ever heard any difference? No, I haven't, but I still do it. Film capacitors are a little bit more expensive, probably double what the electrolytic will cost you, but in a project like this, who cares if you're going to spend an extra $10 or $20 on film capacitors over electrolytics in certain spots. They are known to have a more ideal frequency response, a lower distortion floor. Some people will swear that they can tell the difference between a film capacitor, the way it sounds, and an electrolytic. And like everything with vintage audio, you do your own research and you do what you want to your equipment. I've got a lot more to show you in this video ahead, but first I want to talk to you for a minute about what we've gone over with this F2570, talking about the tools, the techniques, the schematics, etc. And then we'll get back into it, and there's a lot of good stuff coming up. But first I want to go over a little bit as a summary of what we've gone over so far. I know I've talked quite a bit about this F2570 equalizer amplifier and the issue I had with it, but I hope you see how I mixed in tips, techniques, how I approach any problem. And this happens to be the phono section of this integrated amplifier, but it can be any piece of vintage audio equipment that you have that has an issue. You approach the problem the same way. First, you narrow it down to where your problem is, and then you go through the same techniques I used, the same hand tools, the same specialized tools. And then you've got to have the service manual, and you've got to know how to use the service manual. And it has all the information you need to repair your problem like it had to repair my problem. And it took a little time to go along there. I tried to put it in a flow that was interesting, I hope, the best I could, without dragging it on, without going too quick, trying to show you that this is something that possibly you can do yourself. You may not be able to. There's limits to everything that each individual can do, but I tried to show you and give you enough information to where you may be able to fix your own piece of equipment, because as you guys know, it's just hard to find anybody to do that. So to show you that it is possible, I guess, is what I'm trying to do in the most clear way I know how to put it into a video. While I'm talking about how to repair your own equipment, I think it's a great time to bring up my second Marantz 2500 that I'm working on. As I work on this video, working on the software, it's sitting right next to me here. Some of you may have seen my Marantz 2500 video that I did recently on my original 2500. This second one, I've had some unique issues with it that I didn't have with the other 2500, but the main reason for bringing up a Marantz 2500 and a Sansui AU9900 video is because I think these are issues that can help you down the road with your piece of equipment. Here's a few of those issues I had with my Marantz 2500. An open inrush current resistor, wiring errors on the amp assembly, incorrect Zener diodes in the power supply, a totally broken shaft on the oscilloscope level control, a partially broken shaft on the selector switch, a broken dial lamp housing, and a burned out stereo lamp. And this was just the beginning of my troubles. Do I have a bad transformer? Please don't have a bad transformer. In the video, I show you how I repaired each of those issues, so if you haven't seen it, click the link down in the description and make sure you check it out. And while you're at it, check out my first Marantz 2500 video if you haven't seen that. The link's down below in the description area also. Both of the 2500s had different problems, but they're issues that you could have with any piece of equipment. And these videos and what I did to repair those issues can help you keep your piece of vintage audio equipment operating. All right, it's time to get back into this AU9900. Now with this phono problem behind me, I can move on. Earlier I tested everything else out, and everything else seemed to work fine. Now still have problems with scratchy controls, but I'm pretty confident. I don't have a little issue with audio coming and going and stuff, but I'm pretty confident when I get in there and I deoxit those, that's going to fix it. So now I can move on to some more assemblies. And I'm going to work on the 2568 regulated power supply. It's here at the top of the unit, and it's mounted very close to where the phono card's mounted. It's real easy to come out, real easy to change out those old electrolytics, which you guys know that's what I'm going to do. So I'm going to get in there and get those changed out in this power supply. I'm going to be using Nishikon PW series capacitors in the power supply, and that's what I normally use. But as I've mentioned to you guys before, just buy a quality capacitor, and it's going to be better than the 50-year-old one that you're going to be taking out of your piece of equipment. Once I got the replacement capacitors installed, I took a look at my work and made sure it looked good and made sure everything was fine before I went ahead and reinstalled it into the 9900. And in this case, like in a lot of cases, I'll go ahead and I'll give it a try. I powered the 9900 back up, It went through its startup sequence just fine and powered up, so I'm able to go on to the next step. So the regulated power supply has been rebuilt. Now it's time to take the bottom cover off. Here I can see this is the 2567 protector board. It looks like another board that we can get at. Right here, you don't have to take nothing else out. I can tell here somebody has been here before. Like you'll see, like on, I don't know if you can see on this board, there's a 14 road here, there's a 12 and a 13. And so what somebody did, right, so they didn't get mixed up, they wrote a 14 on the connector and they wrote a 14 on the board. I don't have a problem with people doing this because they're not all keyed and somebody was being careful. And what's wrong with being careful? Better than blowing up your stuff, right? So I don't have a problem somebody writing in here. And I'm sure it was done just so when they got this all undone, they could get it back together. I'm going to start doing this 2567 assembly. The 2567 protector assembly did come right out after removing those 8 screws. This will be pretty easy to work on. So I'll see what capacitors. We've got a couple here on the back and several here on the front. So I'll get those together and change those out. There's 2 under here, and you have to loosen these. These were glued. You have to pull them back. Here, I stopped the video. Do you see the glue on this capacitor? There's always been controversy about this glue and what it's for. And I'm just going to tell you what I think it's for, even though I don't really know. This is just my best guess, because I've never seen anyone really for sure tell you what it's for in a piece of vintage audio equipment. And what I think it's for is by the middle 1970s, when this unit was built, it was built, these assemblies, with auto insertion machines. There were reels of components that came down in a machine. They took a raw board, a bare board, and these machines put the parts into the assembly. And the only parts that weren't able to be put in were larger parts, like transformers and like these capacitors. So what they would do is use the auto insertion machine, put in all the smaller parts. These machines would put the parts in perfectly, actually pinch them a little bit, so when you went to wave solder them or flow solder them, they would stay in place. But there was no way to do that with a larger capacitor like that's on this protection assembly and in various other places in vintage audio equipment, usually in the power supply areas. So what I think they used this for was for assembly. Is they auto inserted the parts, then they brought back this assembly with all the parts in it except for the larger parts, like in this case, the electrolytic capacitors. Because if you just put those capacitors into this board, they're going to rattle around. They're going to move. And there's no way that they could handle these, get them to the flow solder machine, and make sure that those capacitors were in perfect position. So they had to hand assemble it. So somebody, by hand, took these, put them in the board, glued them. And that way, they stayed there. This adhesive kept them there. Then when they went to flow solder or wave solder this assembly, everything was perfect. So that's what I think this was used for. When removing these capacitors that are glued down in some method, an X-Acto knife works great. You just break that seal, that glue a little bit, and they'll come loose. Now, one caution, you got to make sure the pins are unsoldered well before you start trying to loosen this up. So you can get the glue a little bit loose, and a lot of times you can see the pins moving, and then you know you've got all the solder out of the holes, so you don't rip those eyelets out, because if you don't have it unsoldered well and you haven't removed the glue very well and you go to try to wiggle it and you think, well, I just got to break the glue loose, and if those pins are still attached, you can damage the board very easily. I've got the new electrolytic capacitors installed in the F2567 power protection unit, and now reinstall it back into the chassis. And as I always recommend, whenever you work on an assembly, if you can, if it's easy like it is in this case, give the unit a try. Don't get too far ahead of yourself. If you got a problem, you know where it is. So I'm going to go ahead and power it up and make sure everything's still okay. Let's give it a shot here and see what happens. So here we go. Well, we got our protector light, which is normal. And I heard that distinctive click right here from the speaker relay that is on the 2567 protection module. With that assembly behind me, I'm going to stay in the bottom of the chassis and move over to the F2580 driver assembly. Just like with the protection board, someone's marked up the connectors and marked up the board so they know where they went when they took it apart. They put it back together, and as I said before, I don't mind that at all. And you don't really see much of the driver assembly here. It's really difficult to see it. All you see is some cables hanging down in there, and that's about it. I guess we got to go up to the top here for a minute and just see what we've got up there. I've got the AU9900 laying flat now. In the last part of the video, we had it up on its side. What we're trying to get at is apparently under this cover, the driver unit. So I'm going to go ahead and take the screws out of that cover. It looks like there's 2 screws, and see what we have. Alright, I've removed that cover, and it looks like up here we just have this one connector. Got the AU9900 back on its side after we took the cover off the top of the driver assembly to see what we had. We unhooked that one cable. We're going to go ahead and unhook these guys, and as I said, somebody previously marked them, so we're good to go here. After removing the connectors and a couple screws, this feels pretty darn loose. Is that going to be it? Well, what do you know? Well, whoever designed this, that's pretty darn easy, huh? I wish it was all that easy. We've got a couple, we've got some wire soldered on the back, but holy smokes, right? I've got this thing right out in my hand. So isn't that nice? Go ahead and replace the capacitors we need to do on here. In the driver assembly, again, I'm going to be using Nishikon components. You don't have to, just use something decent. In this assembly, there's some electrolytics, and there are also some bipolar capacitors. And bipolar, that's one term for them. You see the big BP on the ones I'm using, so that's why I'm saying bipolar, but they're also called non-polarized. Those capacitors you can put in either way. It doesn't matter. It isn't polarized, so you don't have a negative and a positive. Pick whichever way you want to put them in and put them in. And I'm also going to be using some more film capacitors on this assembly. There's a couple electrolytics that I'm going to change out for film. So let me go ahead and get that done. A few minutes ago I was talking about the capacitors that are glued down onto assemblies. This driver assembly has a couple of those capacitors. What I'm showing you here is the X-Acto knife that I use. It works great for doing anything like this. The glue, it kind of has a consistency of kind of like rubber cement, I would say. Now, some of it's dried out, and you'll find out when you're trying to loosen this glue up, some of it just chips right off. But I think originally it was more like rubber cement, and it's kind of flexible, but it's easy to get through with an X-Acto. Once you start moving that capacitor, you can see it starting to break loose. So I just wanted to show you the X-Acto knife I was using. Another thing that I want to bring up about this assembly is it was modified. It has several cuts on the artwork. It has several wires installed. It has 2 resistors that are added to the back of the card. Now, I'm not sure where this was done at, but I'm assuming it was done at the Sansui factory, especially with those 2 resistors on the back. When a piece of equipment is designed, can be any piece of electronics, they design it, they validate it, but at some point they put it into production, and they produce, or have someone produce, thousands of these raw boards to be used in their equipment. And the way it looks, they had some sort of an issue after they had these boards made, and they had to do a modification. And that happens sometimes. So an engineer will come down and say, you've got to cut here, you've got to cut this ground pad here, you've got to cut this ground pad there, you've got to put a resistor here, you've got to put a wire there to fix some sort of issue. Now, I'm not 100% sure about that, but it didn't look like the board had ever really been worked on. It didn't look like the board had been in some way damaged and they had to do all this work. It looks like a modification to me, like something that would have been done in the 1970s when you've got a board that's got a problem and you've built 1,000 of them or 5,000 or however many, and you've got to go ahead and modify it. And that's what they did. They'd have rework people go ahead and do those cuts, put in those wires, and then be able to save those boards because they didn't want to throw them away. They're expensive. So it was more practical to have them modified, do the cuts, add the wires, add the components, and then you can still reuse them. We've gotten our 4 electrolytics changed out, these 2 and these 2, couple bipolars that were here and here, and then we changed out 2 of those little electrolytics, those 1 microfarad electrolytics for film. So I think she's all set to go. I think now I'll pull out the heatsink and power transistor assemblies. I think the way it looks like there's a total of 8 screws, and these look like separate units, so it's like 4 per unit on the left and the right channel. If I put the driver assembly back in right now, I think I'll take these guys out and service them. Our previous worker had marked our cables for us, so it looks like these guys would have to come off. I'm looking up in there. I don't see anything else. So let's just see what we get. I mean, I've got the whole unit. I just took the whole unit out, so that's nice. That came out quite easily, right? What we'll do is it looks like this unit has the original Sanken output transistors, which is again nice, right? Nice to have. Now we'll get the other one out of the chassis. We'll go ahead and get the screws out of this guy. I'm going to reseat these original Sanken output transistors. I'll remove each transistor. There's 4 transistors per channel, total of 8, and I'll install a new mica insulator, and we'll also put in some new thermal joint compound. In this one's case, there's 2 screws. You're going to pull these 2 screws, and this transistor is going to come right out in my hand. This compound, it's some messy stuff. You know, it just is. There's no way to do this without getting a little bit of a mess. Just expect that, and also very, very, very thin layer of thermal compound, both on the heatsink side of that insulator and also on the transistor side of that insulator, but very thin. So we just pull these and screw these screws that you can probably see there hanging on the end of my screwdriver. And what you do is right here, you can just grab it with your finger, the power transistor, and just rock it a little bit. Well, there she is. I'll move him aside. There's a little mica insulator in here, and over the years, it kind of becomes part of the heatsink. I'm pulling on it here with my pick a little bit. I don't know if you can kind of see it coming up, and then bang, there she is. What we want to do first, and then give it a moment to dry, we're going to clean the heatsink with some alcohol. And I'm going to take these power transistors, this side, and just clean them up. All right, just clean them, make it nice and clean. What I'll do now is get out a few of these insulators. What you do, I'm going to put the insulator up here and try to put my hands out here. I'm going to open my tube here of thermal compound. Just get some on my finger. And as I said, you don't need a lot. You know, that's the whole key. You don't need a lot. You know, I'll try to show you here on the back of the insulator, and then place it onto the power transistor. And this side we haven't done much, right? We've got a little bit of a mess over here on the side, and what you do is you just kind of set it in there. Actually, when you screw it in, it's going to set in, but I just give it a little push, and that's all you got to do. You know, you just want a very thin layer on the other side, and put this guy right back down in his socket, right? And we know it can only go one way, so let's see here. There we go. So you do that 8 times is what you're going to have to do it. So there's one. This transistor's got a better chance of lasting longer because it's going to dissipate heat just like it was brand new now. All 8 power transistors have been reseated with new insulators and new thermal compound. So we're about ready to reinstall them now. I'll now reinstall the driver assembly as well as the 2 heatsink power transistor assemblies. So all 3 of these are ready to go back in, and then we'll hook it up and give it a test. We're gonna give it a shot here. So let me come down here to our on-off switch in the front. I'm gonna head and flicker on. Let's see what happens. Well, our protector light should be. It went green. That's good, huh? You can hear that speaker relay. That's always a sweet sound in an old piece of vintage audio equipment. So let's see if we've got some sound here. Yeah, everything seems to be fine. I've got the CD player sitting here, just hooked up into the auxiliary ports, and both the left and the right channels sound good. Up until now, we didn't even need to remove the faceplate. Of course, we left the knobs on, and we did a lot of work in this unit without having to remove that. Well, now we've got to work on those assemblies that those knobs are attached to. So we're going to have to remove the faceplate and the knobs, of course, and do the work here that's in the front of the unit. To get to the assemblies that we want to in the front of the AU 9900, which are these guys up here in the front, you can see them. The switches, these just pull straight off, but you can see here that there's a hex screw at the bottom of many of them, and many of the controls up here. You can see there's a hole here, hole here. These are, you need a 2mm hex tool to get these out. Once you get all the knobs removed, either by pulling them off or by removing them with the hex tool, then the faceplate's about ready to come off. All you have to do is remove some screws at the bottom and the top of the chassis, and it'll come right off. One other thing you've got to take off is the level set control, which is attached to the volume control, and it just slides off. It's just press fitted on there, and it'll come right off easily. Matter of fact, I didn't even know it was supposed to come off. I started to remove the faceplate, and as I was pulling the faceplate, it actually pulled that right off for me. So I removed the faceplate off of the unit. The only other thing you've got to do to get the faceplate off is to remove the connector that powers the power protector LED over at the left side of the unit. With the faceplate off, now I'll be able to get to those assemblies in the front of the unit so I can get in there and restore those. So I've got the 9900 back on its side, and I'm just going to take a look here and see how they have everything installed. They're all similar from this era, but they're different. They're a little bit different, and you just take a look to see what you're getting into before you start. And at the front, pretty much all the units, again from this era, a socket set and a Phillips head screwdriver will get the controls loose at the front. Inside the unit, they vary a little bit, and you have to just kind of take a look to see what's the best spot to start. Usually it's progressive. Usually you start from the outside or near the bottom of the chassis and you work your way in. And that's what I'll do with this unit. So I got all the fasteners unhooked at the front, and all the assemblies came right on out for me. So now I've got everything removed from the front of the 9900. It's several assemblies. You can see here on this block diagram, it shows them all, the tone controls and the volume control and the balance and the filter assembly and etc. Some of the assemblies I just had to remove some connectors, and the whole assembly came right on out of the chassis. Some of the assemblies had wiring attached that wasn't going to be as easy to get them out of the chassis, but I really didn't need to. I just needed enough room to be able to work on them on my test bench, so that was fine. Unlike the Marantz 2500 that I recently worked on, where there wasn't enough slack in the cables, and it was very difficult to work on some assemblies. But this Sansui has plenty of slack in the cables, so even though I can't completely unhook some of the assemblies, no problem. I've got plenty of slack, and I can just pull them right on out where I need them, and I can work on them easily. Before I change the components out in each of the assemblies, what better time than to clean all the controls, right? I mean, this stuff is all out here on the table, and we can get in there and clean those controls so they'll operate properly for several more decades. As I said before, you've got to decide on what products to use. There's different ideas of what to use and what to use them on. I can just tell you from experience, I've never had an issue with any of them, any of the Deoxit products. I use several different ones. As I said, I've got the liquid variety also of them. Those are used in some spots, but I don't think you can go wrong. I guess if you're going to just buy one spray, the D5 is the spray. I'm going to pause the video for a moment to go on a public service rant involving Deoxit D5 and the 2 can options that are available for you guys to purchase. Now let me tell you a little bit about Deoxit D5 and the different cans. This can is a newer can that has this big head on it and this big yellow straw. Easy to identify compared to the old one that has an adjustable spray, low, medium, and high, and a little thin straw. Pretty easy to tell them if you see them. Don't buy this one. Don't buy the new one, the yellow one. Oh, what garbage. It really is truly garbage. Not the product, the can, the type of can it is. This thing sprays enough Deoxit every time you push it to clean 50 potentiometers. It's ridiculous. And makes a mess all over the place. It's just terrible. And this thing here, this yellow piece that comes out, it's barely flexible at all. And you'll see, though, I do have a use for this. I still use it. You may be able to notice, I don't know how well you can notice, you see I've got one of the red straws inserted in the yellow straw. And can you see there's a bend in it? Well, it didn't come that way. I did that. And what this one does have one advantage in is you can get in further. If you can see this, I don't know if you can tell. See, this has got a big head on it. So really where this straw starts, I have to move this one a little bit forward. Where this straw starts, you've got a couple extra inches in this crummy can I hate. So it does have its purposes, but for the most part, get the D5, get the old one with the adjustable spray, low, medium, high, and you just need low. I wish they had ultra low. They don't, because all you need is a little bit of this and then a lot of working of the controls, and you'll be set to go. Now, later on here, I'm going to show you about this curve in this tube. It didn't come that way. I did that. So I'm going to show you that further ahead. But that's just a little bit of a rant. Don't buy this. Don't give $5 for this. Don't take 2 for $10. Just don't. Don't buy this. Don't buy it. Don't buy it. Buy this one. This one with a little straw, adjustable heads. And these are still available on eBay. Now look what you did. Now you took the top off. All right, let's get back to cleaning the controls on this 9900. If you're going to buy 2, get some F5 too. But, you know, as I said, I never had an issue, so I'll go ahead and clean those guys up, and then we'll start changing components. Probably the biggest mistake when people are cleaning controls, after spraying deoxit into them, they just don't exercise them enough. Once again, I know this will sound ridiculous, but you've got to do these back and forth and back and forth. You've got to do them 50 times to be sure. Could you maybe just spray something in there and turn it once or twice and get lucky? Sure you could. But the first time that you disassemble a unit like this to this level and you get it back together and you've still got a noisy, let's say in this case I'm doing the volume control, right? And you've got a little static, you know, that's like a normal thing that you'll have in these old units. And so you get in here, you clean it, you put it back together, and you still got static. And 98% of the time, that's going to be because you didn't exercise these controls enough, and you just want to overdo it. And I'm telling you, it's a very good idea. Guess how I learned it? Because when I first started doing this, I thought, you know, give this guy here a spray, spray down in here, spray down in here, spray, and I don't know, you know, 3-4 times, that should do it, right? No. Just don't do that. You've taken all this time to get this apart. You just want to do it right. So when you get it back together, you won't be back in here ever again. So just do it more times than you think you should. As I said, about 50 or so. And that'll make sure that you get these things cleaned up, all the controls cleaned up properly. Okay, I'm going to start changing capacitors on the F2573, which is the filter circuit board. What I want to show you though real quick, I mean, I just thought about this. I just showed you a little bit about the use of deoxit, but here's a great use for liquid deoxit. There's the D100, comes in a bottle. Just take a couple drops, maybe 3, on the end of a Q-tip, and what a great way to clean these pins down through here. You don't need much. You know, you can get in there and clean these pins up. This unit's 45 years old. Why not do this while you're here? Takes you all of a minute, right? And so that's a great use for liquid deoxit. All right, so let's get started with the capacitors. The 2573 filter board has only a couple capacitors in it, a couple bipolars. And again, I'm going to use Nishikon. I've used those before, but if you got another favorite brand, just use a name brand and they'll work good for you. So let's get started. Okay, we've got the two 3.3 microfarad bipolar caps changed out. So this board, the F2573 filter board, is all ready to go. So we'll go to the next one. This is the 2576, the tone, bass, and treble board. Looks like the same thing. Looks like we've got maybe, I think those are all bipolars. Yep. So we got 4 more bipolar capacitors to change, and we'll do that now. On this board, on the 2576, soldering and desoldering's a little bit more complicated because you've got all these wires that are soldered on the back, and some of the leads that we need to get to are pretty much where these wires want to lay down. Okay, we've got the 4 bipolar capacitors changed out. The 2576 bass treble controls all set to go. We'll work over here closer to the chassis on the, you may have recalled a couple of the assemblies wouldn't come all the way out, and there's only a couple of wires attaching them, so no big deal. We still got plenty of room to work on them. One's the F2574 buffer amp, and the other, this one here, is the F2575 tone mid-range control board. 4 bipolars changed out of the F2575 assembly, and we'll go on to the next one, which will be the 2574. The 2574 buffer amp assembly has 2 bipolars, another a pair of 3.3 microfarad 25 volt bipolars, and on this board there are 2 10 microfarad 50 volt electrolytics, so we'll change those 4 out now. Got the 2574, the 4 capacitors changed out, 2 electrolytics, and 2 bipolars. So I think we're about ready here to start reassembling. We've got all the capacitors changed out. We'll start putting everything back in the chassis. We've changed out our capacitors from the boards at the front of the AU9900, and we're ready to fill this empty space back in again. So we pretty much go in reverse. What we would start with, this was the last module we took out, right? This was the volume control, and it sits way at the top of the chassis here, up here. So that's where we want to start, just work our way through it. Gonna try to make a connector sandwich here. Remember the mid, this is kind of the way it goes more or less, right? When it's up in the, when it's in the chassis. Bass and treble are on this one, the mid-range is on this one. So I'm hoping I can kind of hold this together. That's my hope. These guys, I'm not really worried about, you know, getting them in there. There's a lot of slack in these. If I can get this piece in, I feel pretty good that I can probably get the others in. But as we saw taking it apart, it was pretty darn tight, right? So I don't know here what we're gonna run into. There's the mid. I've got the mid in the front. I think I've got the, hey, all 3 popped in. I mean, that's a good sign. I mean, sort of popped in. All right. Are you not jammed up anyway? No, that's all right. And we know where that guy goes. Okay, well, I'll take that. See, again, if you worked on these every day, right? I mean, this is only 9,900 I've ever worked on. I'm sure there's a proper way, you know, there's a system, like everything. But, you know, all these units are similar. You know, you're going to run into something like this on every unit. It won't be the same thing. It'll be something different. All right, I've got everybody snugged up there in the front of the chassis. Make sure we've got everything back in neatly. Fortunately, we didn't have to cut a lot of the original tie wraps, which is always nice. You know, is it a big deal? If you got to cut them, you got to cut them. We had to cut some before, as you recall. But if you can leave those original ones, I don't know. I just think it's kind of cool if you can do it. So I tightened up everything here. Let me give you some light here. Down here on the power switch, and here we go. Okay, well, that's a good first sign. And let's see what we got. Let me CD running. Yeah, okay. Well, this is our volume. Let's see what happens. Well, once again, as you know, real quick test there. I could tell the left and right channel were working. I'll test it a little bit closer. With the copyright laws, you just can't keep any type of commercial music running for too long. The first thing I want to do is to get the faceplate back on the unit and get the knobs back on and move on from there. I've got the faceplate just loosely sat on to the chassis. What we want to do real quick is just power it up and make sure that power protector LED is working. Remember we had to unhook that? Because once you screw this guy back on, you put your knobs back on, what a pain in the hiney. You got to take it all back off. We're good to go. Now I'll put the 5 screws back in the faceplate and get the knobs put back on, and then we can move on. I've reinstalled the faceplate and the knobs. We're getting close here. Before I reinstall the bottom panel, there's a couple things I want to do. One is we haven't looked at the filter capacitors at all, and I'd like to do some measurements on those, and also like to take a look at the bias down here. I think it's an easier place to look at it down here in the bottom. I think we can get on those emitter resistors easier down here. I have a Peak Atlas capacitor tester. It's an ESR 70, that's the model. It's an excellent little capacitor tester. Hold it in your hand, as you can see. Has 2 leads and gives you a pretty good idea about any electrolytic capacitor and what kind of shape it's in. I am going to replace all 4 no matter what they test, but I just wanted to show you how this little device works. These filter capacitors are 45 years old, 6800 microfarad capacitors. So let's see what the capacitor tester tells us we've got. 7800. Alright, so on the surface that seems alright. DSR for these filter capacitors, that seems, you know, in range too. But as I said, doesn't matter if they test good or bad. I'm going to change them, but it's a good thing to know. I've got to have to order those, and I may be using this amplifier before I get to change them. And so it's a good idea, so you don't look in here and you've got something extremely wrong that you can't go on. All of these look like they test out. Now I'm going to check the idle current. AB class amplifiers like this one has a specification for its bias current. We're going to go ahead, I'm going to use 2 meters. I mean, this is always the best way of doing it if you can. You've got 2 meters because we've got to hook up to the 2 channels here. If you only have 1 meter, that's okay too. You just got to do 1 channel at a time. Always, 100% of the time when you're hooking the leads up, turn the power off. I'm going to use these little grabbers. They open up, you can kind of see, I hope, maybe not. As I push this down, like a plunger, these little 2 pins come out, and when you release it, they grab. And so you can see it's all insulated. If something does happen here, it falls off, you've got a lot better chance that it's not going to short something out. So using the service manual's procedure, I went through, adjusted the idle current, I checked the DC offset, and then I was all set and ready to put the bottom cover on and to get this AU9900 into some bench testing, and then after that, to have it make some music. I just want to go over a moment the equipment that I'm using. I'm using a signal generator up here to generate the tones that I need. I also have my multimeter here that I usually use him. I've already gone through and set up the idle current, made sure that was correct, and also checked the DC offset. And I just keep him in here in case I want to take a look at anything. I can, down here on my audio analyzer, I've got a little bit of a gap here in these connectors, so I can go ahead and use my leads here and get down in there if I want to see anything with the multimeter. So I usually just keep that there. And then, as I said, I've got my audio analyzer here, my Sound Technology audio analyzer, which is a piece of vintage equipment itself from the 1980s. Also, I've got the load resistors here, which are 8 ohm, 300 watt. You may have noticed the audio analyzer sitting here recording about 27 watts per channel. And also I mentioned the 8 ohm load resistors that I'm using. The reason I'm doing this, along with injecting a 1 kilohertz sine wave, is I'm preconditioning this AU9900 just like they would have done in 1975. And when I say they, I mean the manufacturer or a magazine like Stereo Review or High Fidelity that would be testing this amplifier. In 1974, just a year before this unit was produced, the Federal Trade Commission, the FTC, changed the rules about how an amplifier is measured. And the reason they did this was starting in the 1960s and up through the early 70s, what was happening was manufacturers were exaggerating their power output. So you had things like, maybe some of you guys have heard of music power. Something will be rated so much music power, or so much peak power, or whatever, some other name for exaggerating how much output power a particular amplifier can put out. In the late 60s, H.H. Scott, which for you guys that don't know, built some wonderful equipment in the 60s and into the 70s. Them, Fisher, McIntosh, Marantz, several others were making quality products, but mixed in there were these manufacturers that were exaggerating their products. So what was happening, people were going to the store and they were looking at an H.H. Scott receiver, and it was 30 watts per channel. Then they looked at Brand X receiver, and it was 100 watts per channel. And the Brand X receiver was half the price of the H.H. Scott. So they were losing business. So H.H. Scott had an engineer by the name of Daniel von Recklinghausen, and he produced a paper that the FTC used to come up with the amplifier rule. Because Scott was one of those companies, as I indicated, they're like, we got to do something here. So we have to have some sort of rules of how an amplifier is tested. One of the FTC rules in 1974 was to run whatever unit under test at 1/3 power. Well, I'm running an AU 9900, about 80 watts per channel, 27 watts per channel, is about 1/3 power. And to run a 1 kilohertz sine wave into the unit for 1 hour under an 8 ohm load before you do any testing whatsoever. So what that did, that weeded out the music power people and the peak power people. And so if you're building a good product, or if you weren't, this rule, if you're going to sell in the United States, you had to meet it. You weren't going to get around this rule. This is a government agency here in the United States, and you're either going to follow the rule, just like a UL listed product, or you're not going to sell them. So that ended this exaggerated peak power, music power. Everybody had to use the same rule. So I asked ChatGPT, why is 1/3 power the maximum power dissipation with an AB class audio amplifier? And here's the answer I got. Okay, I'm almost sorry I asked. Let's get to the summary. So in English, what ChatGPT is trying to say is that 1/3 power in an amplifier like this 9900 that's biased class AB, that's in this amp's least efficient operating range. In other words, when you run this amplifier at 1/3 power, it's going to get as hot as it can get, and extremely hot. And many manufacturers had to re-rate their equipment or use bigger heat sinks so the equipment wouldn't fail after running an hour during this preconditioning test before the testing even started. There's no way to simulate this with music like you guys at home, because you've got those soft passages, those peaks, and you have those milliseconds up and down that gives these transistors and these heat sinks time to dissipate heat. But when you're inputting a sine wave like this and just holding it there is no break for this amplifier or any other amplifier that undergoes any type of a bench test like this. So this is one reason why an amplifier like this 9900 is still operating almost 50 years later, because when it's under normal use, it's hardly being worked at all compared to what it was engineered to be able to do. Another reason was the exchange rate between the US dollar and the Japanese yen. So I asked ChatGPT to tell me the differences between the exchange rate of 1975 and today, and this is what it told me. So as you can see, there was a huge difference in the exchange rates between 1975 and today. The US dollar went a long way in Japan in 1975. It was approximately 3 times more valuable than it is today. So there was no need for any of these Japanese companies to take any shortcuts in making the best product they possibly could. So after putting in my 2 cents, I asked ChatGPT why it thought the Japanese stereo products were made so well in the 1970s. I don't think you can argue for any of these 4 reasons that ChatGPT came back with. The Japanese always have been meticulous with the way they do things. It's just part of their culture. It's part of their nature. It's how they live. It's what they do. So none of this really surprised me. And I think you add that together with the exchange rate, which was incredible at the time, and even throw in those FTC rules that came to play. And you combine all of this together, and this is why you've got vintage audio equipment that is still operating like it was brand new 50 years later. And I believe this equipment, much of it will be operating 50 years more. Most of this equipment will see its 100th birthday, and it'll still be making music. So vintage audio equipment didn't just get to be so good by accident. There was a number of reasons why this equipment still operates today, and I just wanted to go over some of those. So now I'm going to get into that bench testing that I talked to you about a few minutes ago and show you what this AU9900 can do. So running up the left channel here a little bit, 0.04, going to turn it pretty good here. Let's see what we get. About 30 watts a channel at 0.03, 0.04, 53.7, 0.04, 76 at 0.05, a little over 80, 0.06. Look at that. Just sitting right there. I mean, easily running that 80 watts under spec. And once again, this piece of equipment is almost 50 years old. It's running like it came off the assembly line in Japan in the middle 70s. So I'm real impressed with that. Let's go ahead and just click over here. I'm not going to leave it here forever. I mean, this is running hard, right? I mean, it's never going to run this hard, but it's nice to see that it can. And we're about 83 at 0.05, right in there for the right channel. So that's pretty darn good. So back to the left channel now. So we're over 80 watts, 81, 0.05. 0.05, 82. I mean, she's holding up strong. Pretty amazing, 50 years old. It's doing this. 0.06 at 84. Now 0.07 at 80. We're going to make it 0.08. Right there, about 85 watts, 84.8. She's going to roll over here on us. Let's take her to 85. 85.2, 0.08. So that's pretty amazing. That's outstanding performance. And I'm holding it right here at 85 watts a channel. 50 years old almost. Amazing. So I'm going to run it back down here now. I'll run her back down to my... There we go. And let's give her a break here, huh? I'm going to run down the volume control here. Solid as a rock, 85 watts per channel at its rated distortion. So that's pretty amazing how well this equipment can operate. And I want to tell you, these load resistors are probably, without saying, real hot. I'm touching the AU9900 over here, the case. Obviously I can't get my hands really on the heat sinks themselves, because I've got the cover on, but, well, she's warm. No big deal. This could run 24/7 just like this. This isn't hot at all. I just wanted to run up the left channel like I did the right channel. And I'll go through now and do various testing. Really, if you just have 1,000 hertz sine wave, that tells you a lot about how well it's operating. I hope you enjoyed the video. I know it was a long one. There was a lot in here. And any of you guys that are still hanging after your 6th beer or 6th cup of coffee, I really do appreciate you watching it. And if you enjoyed it, please give me a thumbs up down below. And for you non-subscribers, if you enjoyed this video and you'd like to see more of them, please subscribe. And as always, thank you so much to my present subscribers. Y'all have a good day.